Hello and welcome to our DfM analysis of a miniature blender for ME452. My name is Arthur and presenting with me are Lauren, Lily, Nick, and Alexandra. Blenders are kitchen appliances probably most known for making drinks at restaurants like Tropical Smoothie Cafe, but many people also have a smaller sized blender in their own kitchen. Blenders typically have a set of sheet metal blades to chop ingredients and a larger plastic container to hold the ingredients being chopped. This is an exploded view of our mini blender where you can see all of its components. We'll be examining the cap and handle as well as the blade assembly more closely later in this presentation. Since these mini blenders have smaller size and power, they are priced for home consumers who want a small and unobtrusive appliance. A subset of this home consumer group is health and fitness interested consumers who want to take advantage of the on-the-go battery-powered functionality to bring their mini blender with them to the gym or office.
Now I will be discussing the fast diagram for the mini blender. Our task function is to blend food, which is further broken up into primary functions such as chop food, mix ingredients, store liquid, assure dependability, assure convenience, enhance product, and please senses. The primary function chop food can be broken up into basic functions such as break chunks, slice fibers, and cut strips. Mix ingredients can further be broken up into stir contents and liquid, and store liquid can be broken up into basic functions such as prevent splatter and prevent leaks. The sub-function for assure dependability is to protect the electronics, and the sub-function to assure convenience is to allow portability. First assembly sequence can be described as bottom up, starting with the base rubber and then attaching the base bottom. The base top, motor, and power button will be assembled together and then screwed into the top of the base bottom. The rubber body seal will be placed on top of the base top, and the blade rubber will be placed inside the hole on the base top. The blade stem will be placed inside the blade rubber, and blade piece 1 and blade piece 2 will be stacked on top. The body will be screwed into the base top, and the rubber cap seal will be placed on top of the body. Lastly, the cap will be screwed on top of the body, and the handle will be installed inside the cap. Our second assembly sequence is known as top-down and starts by assembling the handle and then the cap. The rubber cap seal is then placed inside the cap, and the top of the body is screwed into the cap. The base top, motor, power button, and rubber body seal are built up into the base top subassembly, and the blade stem, blade rubber, blade piece 1, and blade piece 2 are built up into a blade subassembly. From here, the blade subassembly is attached to the base top subassembly, and the top of the base top is screwed into the bottom of the body. The base bottom is then screwed into the bottom of the base top, and the base rubber is attached to the bottom of the base bottom. To analyze both assembly sequences, sequence 1 and sequence 2 were compared against the following criteria. As you can see, sequence 1 scored much higher than sequence 2 when it came to ease of locating parts and ease of fastening and joining parts. Since there are no locating features in the body when assembling the mini blender top down, the blade pieces and blade stem would have to be attached to the base top before installing them in the full assembly. Also, the base top cannot be installed first because once it is screwed into the body, we lose access to install any of the blade pieces.
This is our function component mapping matrix where the rows are the components and the columns are the functions. So some of the components work together to carry out the actual blending functions, while others prevent splatter and leaks and protect electronics, and the handle allows portability. This is our bill of materials and rough cost estimation where we used the part geometries and weights and the resources given in lecture to estimate the material, processing, assembly, and tooling costs. And so the total came out to $23.53 as an estimate for the cost of one mini blender. And a similar product would be the Blend Jet, which retails at $49.95. And so our estimate falls below 50% of this retail price. And this is our quad chart. And as you can see in the bottom right corner, for high manufacturing costs and high functional importance, while we can't redesign the motor, we can use DFA and DfM to redesign the blade pieces, body, and blade stem to reduce the overall cost of the mini blender.
Based on the leads of the fast diagram, we had made a functional differentiation table with functions that were the same for both customer groups, which include break, chunks, slice fibers, and stir contents. And we had functions that were different for each customer group, which was supposed to allow portability and cut solid strips. Based on that and the function component mapping matrix, we made a component commonality table with parts that were common or platforms, and parts that were different across each
variant, which were modules, and we chose the handle and blade piece.
Product variant focuses on the blade and stem module, which together blends the user's food. To offer more variability for our secondary customers who want a convenient way to get their fruits and vegetables, we created a new blade component called the Julienne disc, which will slice the food into long, solid strips instead of blending it into a liquid. To maintain common interface between the original and modified parts, I produced an identical pill-shaped hole or slot in the disc for a simple replacement of parts on the stem. The next product variant looks at the cap and handle module. The purpose of the cap is to prevent splatter and leaks of the blender contents. However, to appeal to our secondary customers who are always on the go, we modified the cap to have a more sturdy opening for a carabiner clip, which allows for portability by simply snapping onto the strap of a gym or work bag. The platform component of this module is simply the red
assembly diagram. The bottom up version, we created this product family assembly diagram, which you can see is modified to include the new product variant parts, which includes the julienne disc and carabiner. It's also important to note that for the Blade 2 assembly step in the original product variant, there is not a corresponding step in the new variant. Therefore, that's why it's blank. Using the layer differentiation allows for the rubber body steel step to be before Blade 1 or julienne disc step, and thus making it easier to manufacture.